So for this session now, we'll have this section 1.5, chain rule, implicit differentiation, and chain rule and implicit differentiation. So let's start with this problem here. So let W be equal to ln of square root of x plus sine y minus cosine y squared over z plus 1, where x, it's a function of R and S. It's r cubed times x cubed. Your y, it's tangent to the fifth power r, tangent of r to the fifth power plus cotangent to t. So this is y is a function of r and t. And then z, it's just a function of s. So z equals e to the negative 2s. So specifically, you are asked to use chain rule to find partial of w with respect to s. This guy here should be with respect to r. So let's just replace this partial w with respect to r and then partial w with respect to t. So let's start in here. So as you can see, w, it's a function of three variables here. So you have x, y, z, and then your x is just a function of r and s. Your y, it's a function of r and t. And then your z, well, we're lucky, it's just a function of s. Okay? So if we want partial of w with respect to s, so we will need the partial of w with respect to x, because we have the s in here under x, so we will need to pass through that and in order to get that w. And then on the y, we don't have an s, so we won't need the y part here. And then the z, it only has s, so we will need the z. Therefore, we will have here, so partial w with respect to x times partial of x with respect to s. And then plus, so we need w, partial w with respect to, we need z. So partial w with respect to z times partial z with respect to s. So for this, let's just do this part here. Partial w with respect to x. So for this guy here, this does not have any x. We only have this. So this disappears. And then for this, we will have 1 over square root of x plus sine y. And then by chain rule, we multiply this by 1 over 2 square root of x. And then this part here, partial of x with respect to s. So we have this. This is, everything is multiplied by 3r cubed s squared. Okay? And then we have partial of z, or partial of w with respect to z. This guy does not have the z. We have it in here. So this guy here is constant relative to z. So what is this? Instead of minus, we'll get the plus. And we'll have here cosine y squared over z plus 1 quantity squared. So check my differentiation. That's the one that you should get. And then we now get the partial derivative of z with respect to s. So this guy here, we multiply by negative 2 e to the negative 2s. So this is partial w with respect to s. Okay. Next, we want partial w with respect to r. So we have an r for this part, so we will pass through x also to get to that w. This guy here, we also have an r, so we will pass through y to get to this w here. So partial w with respect to r, we need partial w with respect to x times partial x with respect to r. Then plus, we have partial w with respect to y times partial y with respect to r. So in here, partial w with respect to x, okay? We still have this. We still have this part here. This is partial w with respect to x. Correct? So we still have that 1 over square root of x plus sine y times 1 over 2 square root of x. But this time, this expression is being multiplied to the partial of x with respect to r. So we will have 3r squared s cubed. And then we have plus here. We need partial w with respect to y. So this guy here has y. I mean, this guy here has y. This guy here also has y. So we will need both. So quantity, for the ln, it's just 1 over square root of x plus sine y. And then by chain rule, we multiply now by the derivative of sine y because we are differentiating with respect to y. So multiplied to cosine y. And then for the next part there, for this guy here, we know derivative of cosine, it's negative sine. Okay, it's negative sine. So we will have here plus cosine, sorry, it's plus sine quantity y squared. And then by chain rule, we multiply by 2y. And don't forget that z plus 1 on the denominator. Okay? And then this guy multiplied to partial of y with respect to r. So you got this guy here. This guy here, it disappears. So we'll just have this. I mean, it disappears because we need derivative with respect to r. So the derivative will be 5 tangent to the 4r, and derivative of tangent, it's secant squared. So secant squared r. So this is now the partial derivative of w with respect to r. Okay? Lastly, we want partial w with respect to t. So we only have this. So we only need this part here. Okay? So partial w with respect to y times partial y with respect to t. Okay? So partial W with respect to y, we have that already on this part. So we'll just copy it. We'll have cosine y divided by square root of x plus sine y plus 2y sine y squared over z plus 1. So that's partial w with respect to y. Then partial y with respect to t, we have this. This will disappear after differentiating with respect to t. So we will have here times derivative of cotangent t or cotangent function, it's negative cosecant. So in here you have negative cosecant squared of 2t. Sorry, I said cosecant earlier. It's cosecant squared. So negative cosecant squared 2t. Then by chain rule, we need to multiply by the derivative of 2t. So multiplied by 2. So this is the partial of w with respect to t. Okay? Questions? Okay, so for this example, so here suppose z is a function of x comma and x and y and satisfies z plus x squared e to the yz equals sine of y squared minus 2z, where x is equal to this function, y equals this function. So x equals r square root of tangent inverse t, and y equals ln of 4t minus 3. We want to evaluate dz over dt, or partial z with respect to t, where r and t equals 2, 1. Okay, so we know that z is a function of x and y, okay? And then what we can do here is to rewrite this, okay? Rewrite this as z plus x squared e to the yz minus sine of y squared minus 2z. And then, of course, this is equal to 0. Now, this guy here, we'll just let it to be some function in the variable f. So if we just define this as capital F of x, y, z, okay, then what do we have? You have your f. This is x, y, z, but you know your x here, your z here. This is in terms of x comma y. Okay, so you can treat it this way. But this is what we know. We look at by chain rule. So your z, this is in terms of x comma y. Both your x, it is in terms of r and t, while your y, it's in terms of t. Okay? So from here, we can have partial z with respect to t. Okay? And using this guy here, particularly this path here plus this path here, we will have partial x with respect to, sorry, it's partial z with respect to x times partial partial x with respect to t plus partial z with respect to y times partial y with respect to t. Now, where are we going to use this? We'll use this in order to solve this guy here and this guy here. Okay? So you will recall partial of z with respect to x. If we have this function, okay, this is simply negative f sub x divided by f sub z. And partial z with respect to y, this is negative f sub y divided by f sub z. And, partial, if you look at this, okay, as a function of three independent variables, quote unquote, differentiation will be easy. So let's see. This is equal to negative. With respect to x, this is simply 2x squared e to the yz in the numerator. On the denominator, what will we have? We have 1, okay? 1 plus we have x squared y e to the yz, and then minus, you have here, well, it becomes plus, try to check, it becomes plus 2 cosine y squared minus 2z. And then for the partial z with respect to y, we will have, what do we get in here? With respect to y, we'll just have negative again. And then with respect to y, we will have x squared z e to the yz. Then here we will have minus 2y sine, sorry, it should be cosine y squared minus 2z. And then denominator, we'll just copy 1 plus x squared y e to the yz plus 2 cosine y squared minus 2z. Okay? And then you will have these two guys in here, or this guy here, and this guy here, we distribute there. And then partial x with respect to t, let's write it on this side. Partial x with respect to t, this is equal to what? R over 2, sorry, R over 2, yep, that's 2, square root of tangent inverse of t times 1 over 1 plus t squared. And then here we have partial of y with respect to t. We have 1 over 40 minus 3. By chain rule, we multiply by 4. And then we can evaluate now at 2, 1. Let's see. X of 2, 1. So this is equal to 2 square root of tangent inverse of 1. What's tangent inverse of 1? That's pi over 4. So this is equal to square root of pi. And then y 2, 1, this is just, where are we? ln of 1, correct? 4 times 1 minus 3. So that's ln of 1. ln of 1, and this is equal to 0. In order to find z, what we're going to do is to substitute x equals square root of pi and y equals 0 in this equation. So upon substitution, we will get z plus pi, because here we will have a to the 0, which is just 1. And then, of course, here we have square root of pi squared. And then the other side is we will have sine of negative 2z. Or this is also equal to negative sine of 2z. Now, to solve this, one can do the following. So you can consider the graph of w equals z plus pi, and also w equals negative sine 2z. So you can look at the graphs on the wz plane, okay? And what you will get is, for example, in here, you would get the line. This line here, w equals z plus pi. So when z equals 0, we have w equals pi, and then when w equals 0, z equals negative pi here. So you will have this line here, okay? And then for this part here, this is pi over 2. So this is pi, this is, let me use a different color there. This is your pi, this is your pi over 2. And then this is, sorry, this is negative pi. And then this is pi here. And then 1 is roughly somewhere here on the y, on the w coordinate. And then negative 1 maybe somewhere here. And then if you try to graph negative sine 2z, you will have something like this. So you have negative, so of course when z equals 0, we will have when z equals 0, you have sine will be w will be equal to 0, so it's here, okay? And since it's negative, the rise is somewhere here. So you will have something like this. Take note, at negative pi over 2, you will have 2 times negative pi over 2, that's negative pi, and sine of pi, that's equal to 0, okay? And then if you continue the graph, it will be somewhere here. So eventually what I'm saying is that these two guys here, okay, intersects at z equals negative pi. So these two guys here will be equal, okay, will be equal at z equals negative pi, okay? So here we will have z equals negative pi at rt equals 2 comma 1. And therefore we can now find the value of partial z with respect to t. We now have the values for x, y, and z at the point 2 comma 1. So let's see. At rt equals 2 comma 1, partial z with respect to t, this is equal to. So let's do this part here. So let's do this part here. What we will get is quantity negative, and then we have that fraction. And then here you have 2 and then square root of pi squared. So that's 2 pi. Okay. And then this is e to the 0, so it's just 1. And then here you have 1. This part here will be 0 because of the y here. Okay. And then you have here 0 again. So on the denominator, you will have 1 plus 2 cosine y squared, that's 0. And then you have negative 2, okay, times negative pi. So that's cosine 2 pi, correct? And then for partial x with respect to t, partial x with respect to t, evaluated at r comma t equals 2, comma, 2, comma 1. So we look at this part here, okay? We will have, so r times 1, so r that's equal to 2, divided by, you have 2 times tangent inverse of 1. You have the square root. So you will have 2 square root of tangent inverse of 1, that's pi over 4. Okay. And then times 1 plus t squared. So this is 1 plus pi. Oops, sorry. T equals 1. So 1 plus 1. So 1 plus 1. So that's for this part here. And then for the other part, we will have plus quantity. You have here, so we look at partial z with respect to y. So we look at this part here. We will have negative square root of pi squared. That's pi. And then z, that's negative pi. And then e to the 0 again. And then you have 2 minus 2y. So that becomes 0. And then on the denominator, I will have the same denominator as in here. Okay. So same denominator. So it's just this guy here. So 1 plus 2 cosine 2 pi. And then this guy here, it's multiplied to, you have partial y with respect to t. So you have here partial y with respect to t. That's just 4, correct? This is just equal to 4. So if you simplify, you can do the simplification, but I'll accept this as a final answer. Okay. For our next example, consider the function f of x comma y equals 2 raised to x squared minus y. If x equals r log s and y equals cube root of s over r, find f sub r and f sub s. So f sub r, it's just partial f with respect to r. And again, chain rule. So this is simply, so let's see. Well, both of them. So the function f has x and y, and both x and y, they have here the s and r. So partial f with respect to r, that's just partial f with respect to x times partial x with respect to r, plus partial f with respect to y times partial y with respect to r. So straightforward computation. Partial f with respect to x. So this is 2 raised to x squared minus y times ln of 2. And then times by chain rule multiplied to 2x. Okay. and then multiplied to partial x with respect to r. Partial x with respect to r, that's just log of s, plus partial f with respect to y. So you have 2 raised to x squared minus y times ln of 2 times. In here, we have times -1. Okay. And then now partial y with respect to r, this is, what is this? So you have times cube root of s, okay? Cube root of s. Let me separate that. Cube root of s. And then if we write this as r raised to -1/3, derivative will be -1/3 r raised to -4/3. Okay, so which means we will have here -1/3 cube root of r to the 4. And you can simplify this. So this is partial f with respect to r. And then partial f with respect to s. So this is partial f with respect to x times partial x with respect to s plus partial f with respect to y times partial y with respect to s. So in here, partial f with respect to x, we just copy this part here. And partial f with respect to y, we just copy this part here. So anyway, we will have 2 to the x squared minus y times ln of 2 times 2x. Now, partial x with respect to s, this is what? R over s, and then ln of 10. R over s ln of 10. Correct? R over s ln of 10. And then we will have here plus 2 to the x squared minus y ln of 2 times -1. And then for the other guy, we will have 1 over cube root of r. And then if we look at this, now, you have s raised to 1/3. Derivative will be 1 over 3 s raised to -2/3. So this is 1 over 3 cube root of s squared. So this will be the derivative of f with respect to s.